Hi, everybody. This is the 2023 CINR webinars. And this morning, we're going to start with a session on topic area 1, reactor development and plant optimization. I just wanted to remind everybody that we would like participants to know that the overviews you are going to hear during this session are intended to introduce the topic area and subtopical areas, provide context about the types of ongoing work that is happening in the Office of Nuclear Energy's programs in relevant technical areas, and provide guidance on areas that are clearly outside of the NE mission space. The presentations and Q&A are intended to inform the applicants that you may choose to submit to this funding opportunity and not constrain those ideas to only those being pursued by the programs. The Q&A will be at the end of each final session, so we'll present all the RDO topics, and then we'll have the Q&A for all the topics at one time at the end. With that, we'll turn the time over to our first presenter, who is Janelle Edens, our federal POC. Go ahead, Janelle.
Good morning, everyone. My name is Janelle Edens, and I am the Advanced Reactor Development Team Lead within the Office of Nuclear Energy. We also have on the line Jason Toki, who is the Reactor Optimization and Modernization Team Lead. In addition to Jason and I, we have a number of federal managers on the line who will walk through the various subtopics. And finally, we have our technical experts from the national labs who will be available to help answer any questions that you may have at the end of the session. And we're going to do things a little bit differently this year. We're going to walk through each of the subtopics as well as IRP-1, and that should take us to about 11 a.m. Eastern. And then at the end of that, we will then open it up to questions on any of the topics that we covered in this session. Next slide, please. So before we move on to the subtopics, can you go to the next slide, please, Julie? And then we may need to go back. So before we move on to the subtopics, I wanted to quickly touch on the opportunity available with the OECD NEA NEST program. And NEST ties together university research projects across multiple countries to provide students with a fuller professional experience as they pursue their degrees. So for IRP-1, as well as all of the subtopics within topic area 1, incremental funding is potentially available through participation in the NEST program. And that incremental funding will be provided to allow students to travel to interact with their peers in other NEST countries. And then in terms of what types of projects the NEST program would be most interested in, their highest priority would be projects that advance the deployment probability of advanced reactors. So that would include economics, community acceptance, business deployment opportunities, and applications such as integrated energy systems. So IRP-1 and topic area 1 fit very well within the NEST priorities. I do want to clarify, though, that you're not required to participate in a NEST program if you submit an application to topic area 1 or IRP-1. I also want to clarify that participation in NEST will not be a factor that we consider as we review the applications. But if you do decide that this is an opportunity that you want to pursue, you will need to agree to participate in NEST, and you must clearly indicate in your application that you're willing to join as a NEST project. However, you should not include any anticipated budget requirements for NEST participation, since NEST funding will be provided and tracked separately from the CINR project. And then to provide some insight on how the process works, at the end of the CINR process, once the projects have been awarded, then the NEST program will take a look at which awarded projects indicated interest in participating, and they will make a decision on which projects will be invited to join as a NEST project. Can we go back to the previous slide, please? Okay, so this slide provides an overview on topic area 1. And topic area 1 is focused on reactor development and plant optimization. And in the US, we have set very ambitious climate change goals of achieving 100% clean electricity by 2035 and a net zero economy by 2050. And we fully recognize that we cannot meet these goals without nuclear energy. So that's why in the Office of Nuclear Energy, we're focused on both preserving the existing fleet and driving deployment of these really innovative advanced reactors. But in order to enable that goal, we need to ensure that nuclear energy is economically competitive and it's an accessible source of energy. So with this topic area, we're interested in activities related to advanced reactor development, design, and testing that improve technical, cost, safety, and security issues for the existing fleet and for advanced reactors. And for the advanced reactor topics, we're interested in both light water as well as non-light water reactor concepts, including light water SMRs, microreactors, fast reactors, and high temperature reactors that use gas or molten salt. We're also interested in research related to plant optimization, and we do list some potential examples in the work scope description. Next slide, please. Okay, so now we're getting into the individual subtopics. The first subtopic is advanced reactor development, and I am the federal program manager for this subtopic. And advanced reactors have the potential to offer significant potential benefits, including possible lower cost, enhanced safety and security, greater resource utilization, and simplified operation. But there are still some technical challenges which remain to be addressed to allow future demonstrations and deployments of advanced reactors. So to support that goal of future advanced reactor deployment, we are seeking proposals for activities that can help to address any technical barriers associated with these designs. So your proposal should clearly identify the challenge that's being addressed and how the proposed activities will support the development, demonstration, and future deployment of advanced reactor concepts. I should also clarify here that when I use the term advanced reactors, I'm referring to both the light water SMR concepts as well as any of the non-light water reactor concepts. So we do list some potential challenges that could be addressed here on the slide, but I want to stress that these are just examples to get the creative thoughts flowing, and this list is not meant to be exhaustive. So really any proposal that will help to reduce the technical risk associated with advanced reactors would be responsive to this subtopic. But you will need to explain in your proposal why you believe that what you're proposing is a challenge and the benefits to advanced reactor deployment from addressing that challenge. Next slide, please. So this slide covers some of the ongoing work within NE that's relevant to RDO1. First, we have the Advanced Reactor Technologies Program, and that program funds essential research to reduce technical risk associated with advanced reactor technologies and systems. And within the ART program, there are 4 research campaigns. We have the MSR campaign that's focused on both concepts that have the fuel dissolved in the molten salt coolant, as well as the variant that uses solid triso fuel. Then we have the gas reactor campaign that supports the development and deployment of high temperature gas reactors. And the concepts under development in the US today use helium gas as the coolant, and they also operate at very high temperatures in the 750 C range. Then we have the fast reactor campaign, which is focused on the development of technologies that use liquid metal coolants and operate in the fast spectrum. And then finally, we have the microreactor research campaign that supports development and demonstration of microreactor concepts by conducting cross-cutting R&D activities. Then in addition to the lab-directed research that's funded through the ART program, we're also supporting cost-shared partnerships with industry to help reduce the technical risk for a broad set of advanced reactor designs. And we're supporting a number of projects through the ARDP Risk Reduction Awards, the ARC-20 Awards, and the New Scale and CFPP projects. But I do want to stress that the list above is not meant to be all-inclusive, and it's just being provided to assist applicants in identifying research that's not duplicative of previous or ongoing research. We also hope that this list will help to spark some innovative ideas. There may be some things that we're already doing, but you might have a different or better way of approaching it. So please feel free to submit those ideas as well. I would just recommend that you explain in your application why your idea is not duplicative and how it's different from currently funded activities. Next slide, please. So this slide lists some areas that are not relevant to this subtopic. For example, we're not looking for new reactor designs with this particular subtopic, and your proposed activities, they do need to show some tie to advanced reactors. So solutions that are only focused on the existing fleet would not be responsive to this particular subtopic. I would note, however, that if your proposal is cross-cutting and it does support one of these areas that's not relevant, but it also supports advanced reactor development, that it could potentially be responsive to this subtopic. And with that, I'll turn it over to Jason Toki to walk us through RDO2.
Hey, thanks, Janelle. Can someone give me a thumbs up if you can hear me, or let me know?
Yes, we can hear you. Thank you.
Oh, great. Thank you. We're doing better than yesterday. All right. So good morning, everyone. My name is Jason Toki. I am the team lead for reactor optimization and modernization within the Office of Nuclear Reactor Deployment, or NE52. So I have responsibility for our light water reactor sustainability program, our advanced small modular reactor research, development, and demonstration program, our advanced reactor safeguards program, and integrated energy systems. So this morning, it's my privilege to present to you all on this topic area 1, RDO2, for improving economic competitiveness. So as you heard yesterday and a little bit from Janelle this morning, the topics this year are being written very broad to allow, I think, for maximum flexibility, creativity, and innovation. And I think this work scope is probably the prime example of that new paradigm. If you take a look at the draft work scopes that have been posted on the NEAP website, I think this one is down to 2 or 3 sentences at this point. But let's go ahead and get into it. The problem statement is, the existing nuclear fleet of large light water reactors continues to face economic headwinds, which are resulting in premature plant shutdowns before the end of a plant's viable lifetime. Additionally, the department is working very diligently to try and deploy the next generation of new advanced nuclear technologies, many of these within the next decade. And these advanced technologies must also prove their economic competitiveness for widespread deployment to ultimately be successful. So under RDO2, we are seeking proposals for innovative solutions to improve the economic competitiveness of existing and future nuclear power plants. Proposals to this topic area should clearly identify the challenge being addressed and how the proposed activities will support improved economic competitiveness from existing and/or new advanced nuclear technologies. I do want to be clear here that proposals can focus on one reactor technology type or reactor class, or be more broadly applicable to all reactor types, both existing or new. We're not prescriptive here. To echo some of Janelle's earlier words, we have some very high-level examples of potential challenges that could be addressed under this topic, but this is certainly not meant to be bounding or all-inclusive. These are just some examples. So we have evaluation of cost drivers for existing and/or advanced nuclear technologies. The second bullet, I guess, is probably the big one, development of new methods, processes, or technologies to reduce costs related to construction, operations, and/or maintenance. Modernization of the existing fleet to improve economic performance. And finally, the reduction in uncertainty and safety margin calculations that have historically driven some unnecessarily conservative assumptions, which result in higher operational costs. Can you go on to my next slide, please? Thank you. So slide 2 for me, this slide's intended to give an overview of the ongoing work that NE has relative to this topic area. And here you see sort of the challenge of such a broad statement of work. in that NE supports a wide range of programs and activities that intersect either directly or in a cross-cutting manner with economic competitiveness. Some of these include our light water reactor sustainability program. As the name implies, the LWRS program is focused on improving the economics of the existing fleet to enable their continued operation. LWRS has 5 different pathways or focus areas under the program. These include plant modernization, flexible plant operation and generation, risk-informed systems analysis, materials research, and physical security. Next, we have our Advanced Reactor Technologies program, which Janelle just provided a good background on, but this supports the development and commercialization of innovative concepts, including microreactors, fast reactors, molten salt reactors, and high-temperature gas-cooled reactor technologies. We have our Advanced Reactor Demonstration Program Risk Reduction Awards, and these projects are aimed at reducing risk and technical uncertainty for a broad range of advanced reactor designs. Similarly, our Advanced Reactor Concepts 20 or ARC 20 awards support innovative advanced reactor designs that could potentially have a significant impact on future energy markets in the mid-2030s or later. We have our Advanced Reactor Safeguards program. One of the pathways under this program, the physical security pathway, is evaluating a combination of new technologies and approaches to physical security that are seeking to reduce the upfront and operational costs of physical security to help improve overall economics. And there's also another whole slew of ongoing work through NEOPs, SBIRs, STTRs, and other industry awards. So once again, this is not intended to be exhaustive, but to give you an idea of some of the things we're already working on in this area and try and help potential applicants identify research that is not duplicative of previous or ongoing research that we have. All right, on to the next slide, please. Thanks. And slide 3 is finally what we aren't looking for here. So first and most importantly, I think that applications should focus on research that supports the DOE NE mission, and all applicants should ensure that their proposal clearly makes that tie to the NE mission. My second point that I'll hammer once again is that RDO2 is a very, very broad statement of work. So before applying under RDO2, I encourage all applicants to ensure that their potential topics are not better aligned with other topic areas under this solicitation. You'll see I list a few examples of these below, but once again, this is not all inclusive. And I will offer that I think the NEOP office may be able to help with questions on what topic area is most appropriate for a given proposal, and I'm also happy to help with that as questions arise. So with that, some of the focus areas that we would consider not relevant to this topic, we're not interested in new reactor designs or concepts, the development of reactor fuels, which is covered separately, similarly the instrumentation controls and cybersecurity, which are also covered under their own specific topic areas. So with that, that's all I have for this morning. Thanks for listening. And once we get to the end of the overall topic area 1 session, I'm happy to answer any questions. Thank you.
Thank you, Jason. Now we're going to move on to the RDO3 presentation from Jason Marcinkowski, the Integrated Energy Systems and Industrial Applications.
Hi, I'm Jason Marcinkowski. I'm a program manager for the Integrated Energy Systems program and the Flexible Generation and Operation pathway for the LWRS program. In this topic, we're really looking at co-location. The slides changed on me. we're really looking at the co-location of nuclear plants with industrial applications. It could go both ways between existing new industrial applications being sited with existing reactors, or advanced reactors being sited with industrial applications. So, obviously this has some very large benefits in providing clean, reliable energy or high quality heat with very high availability where it's needed, and it reduces the transmission and distribution costs of moving energy to the applications. So several applications are of interest, including hydrogen, synthetic fuels, polymers, chemicals, minerals production, refineries, and district heating. So those are some examples of some high impact areas that we could work on. We have a lot of work on hydrogen in the LWRS program right now, but nothing like this where we're looking at the actual conceptual layouts of the plant and industrial application. And I'll get into some of that scope on the next slide. Next slide, please. So this slide was, the labels got confused. This is also part of the scope. Projects are sought to develop reference designs for nuclear integrated industrial plants. So this includes tasks such as chemical industrial process models for integrating nuclear energy inputs. So understanding where that thermal and electrical integration can occur within those applications. There are potentially a lot of opportunities to replace existing fossil resources or byproducts that are burned for heat, for instance, or grid supplied electricity. So we want to really understand those processes to inform that integration. And then we want to understand the thermal, electrical, and chemical distribution systems and storage systems that are needed for those integrations, including control system components and sensors. So those are obviously critical to assess the techno-economics of the systems and their viability economically, and for reducing energy use and emissions. So we also want to look into innovative designs for physical protection and barriers, and with the understanding of requirements that are necessary to make those designs. And finally, we can look at nuclear and industrial plant layouts, so understanding how this looks in a real life situation. Having that reference design that gives us a clear picture of where the nuclear plant is located and the industrial plant, and understand the access, the setbacks and boundaries of the two plant systems. So next slide, please. So, well, by the way, I just wanted to mention on the scope, that's not meant to be a comprehensive list of scope, but to give you an idea of what we're looking for reference designs. But what we're not looking for are new reactor designs, and we're not looking for dispatch optimization for controlling multiple loads simultaneously. In this case, we're really focused on each singular application integrated with a nuclear plant. There could be some synergistic applications that could be considered, but really we're trying to look at the singular industrial applications connected to the nuclear plants. So thank you, and I'll be happy to answer questions at the end of the session.
Thank you, Jason. Now we'll move on to RDO4, remote deployment, dedicated power supplies, including siting. And I believe Janelle is going to give this presentation.
Yes. So RDO4 is focused on remote deployment and dedicated power supply applications for nuclear energy. And Diana Lee is the federal program manager for this subtopic, but I will be covering her slides today. Some advanced reactors, such as microreactors, are uniquely suited for service in non-traditional energy markets, such as off-grid communities, remote locations, military bases, and disaster relief missions. And microreactors are a cross-cutting category of very small reactors that can use really any of the coolants under development by any. And because of their small size and some other features, they're uniquely able to service these non-traditional energy markets. And then in addition to that, new large electric loads can pose challenges such as grid congestion, which could potentially be addressed by using microreactors or small advanced reactors to serve as dedicated power sources. So with this work scope, we are looking for proposals that identify high-value niche markets and applications for the use of advanced reactors. And some examples of these specialized markets could include maritime applications, electric vehicle charging stations, and data centers, just to name a few examples. We also list some activities that you could consider in your proposal, such as techno-economic analysis, environmental justice considerations, regulatory requirements, and other site requirements. It would also be helpful to include some really high-level details on the type, size, and output capacity for the reactor that you're considering to support the proposed application. Next slide, please. This slide covers some of the ongoing work within NE that's relevant to RDO4. First, we have our microreactor research program, which is focused on non-nuclear system testing, supporting commercial demonstrations and end-use applications, as well as maturation of innovative components and semi-autonomous operation. In that program, we're also working to establish the MARVEL reactor at INL to support nuclear testing and demonstrate microreactor operations and end-use applications. And MARVEL is planned for operation in the 2024 timeframe. We're also supporting a number of activities that are related to the use of nuclear energy for maritime applications. Our National Reactor Innovation Center, or NRIC, leads a Maritime Nuclear Applications Group. And this group is really a research hub and a resource center that brings together experts from the maritime and nuclear energy sectors to facilitate the demonstration of advanced nuclear technologies for a range of maritime applications. And then in addition to those previous activities, we recently awarded an FY22 CINR project, as well as an industry award to look at various maritime applications for nuclear energy. And then before I move on to the next slide, again, I just want to stress that the list of examples is not meant to be all-inclusive. It's just being provided to assist you in identifying research that's not duplicative of previous or ongoing work. For example, I would not rule out maritime applications as a potential focus area if you have a really innovative idea in that area. We would just not want to see the exact same scope as what we're currently funding through the CINR project or through the industry project. So just encourage you to familiarize yourself with the items listed on this slide. This slide lists some areas that are not relevant to this topic. For example, we're not looking for new reactor designs with this particular subtopic. It would be helpful to provide some high-level details on what type of reactor could support the proposed application, but it really should not be a reactor design exercise. We're also really looking for specialized and unique high-value opportunities for advanced reactors with this subtopic. So if you have a great idea that's focused only on the more traditional integrated energy systems applications, such as hydrogen production, for example, then RDO3, which Jason just described, would probably be a better place for that proposal. And again, if you have any cross-cutting ideas that support one of the topics that are considered to be not relevant, but also supports a relevant area, then that could potentially be responsive to this subtopic. And with that, I'll turn it over to Dan Nichols to walk us through RDO5.
Thank you, Janelle. Good morning, everyone. My name is Daniel Nichols. I am the Artificial Intelligence and Machine Learning Point of Contact for the Office of Nuclear Energy. And today I'll be talking about the RDO5 topic, implementation of artificial intelligence and machine learning. So here in the Office of Nuclear Energy, we've identified that artificial intelligence and machine learning both are critical tools that can support optimization of a wide variety of systems that will enable growth and sustainability of the nuclear power industry. These tools we see as being able to expedite the development and deployment of nuclear reactors, lowering costs and providing faster solutions to unique problems. So we are seeking proposals that leverage these tools to solve problems, and I've included here a list. This is a non-exhaustive list, but for example, structural design optimization, process optimization, economic optimization, manufacturing optimization, hazard detection, and non-nominal condition monitoring, just to name a few. And the goal of this subtopic area is really to promote the growth of the AI community while focusing on supporting the Office of Nuclear Energy's mission. And as part of applications, applicants should describe the AI or the artificial intelligence or machine learning method proposed and explain the expected impact on an identified and intended reactor system. If applicable to the proposal, they should identify the necessary source of data used for training algorithms and describe methods of procuring the needed data for their project to complete their proposed scope. And then if the AI method is novel in its nature, we would like applicants to provide a basis of comparison against conventional methods that are currently being used in different industries to demonstrate feasibility and advantages in comparison to already accepted methods. Next slide. So just to give a little bit of background on ongoing relevant work in the Office of Nuclear Energy that is pertinent to this subtopic. We just wanted to highlight a couple of examples of work. This spans across directed research, NEUP, SBIR, STTR, and industry, FOA. But essentially, past work and ongoing work in AI ML applications includes the pursuit of partial or fully autonomous reactor control systems, expediting material discovery via simulation and modeling, automating, and using machine learning coupled with that material discovery. Computer vision for plant navigation and hazard observation, computer vision for plant navigation and analog gauge observation, as well as observing and identifying hazards in a plant, and then also automating manufacturing of advanced components. Now, this isn't an exhaustive list of ongoing research activities, so I'd encourage applicants who are interested in this subtopic to reach out to NEUP, and they can direct their questions to me, and I can answer more details about ongoing projects. But this just gives a general overview of work that's being conducted currently across various programs in the Office of Nuclear Energy. Next slide. So finally, I wanted to touch on the areas not of interest for this subtopic. And one thing I would like to preface this slide with is to echo the sentiments that Jason Toki provided in the previous slide, was that there are ongoing efforts in other programs that will be discussed in other topic areas throughout the course of the CINR webinar this week, that I encourage applicants who are considering this subtopic to attend all other topic areas to see if their AI application would better fit into those categories. Now, granted, those categories have a focus on their specific topic, which may allow for supporting elements such as artificial intelligence, machine learning, but most of those categories, AI, ML development, should not be the primary focus of the subtopic. Therefore, for this subtopic, we encourage applicants, once they've reviewed and attended the other topic areas, if they have identified that their AI ML solution does not fit into those categories, then this may be a suitable location to apply for funding through this subtopic. So then going over some of the non-relevant topics, associated. This would include nuclear non-proliferation purposes, technology solely for nuclear fusion applications, personal dose monitoring applications, nuclear weapons research and development, nuclear medical isotope production, and nuclear medicine related technologies. Now, of course, there may be applications of AI ML that is cross-cutting with these categories, as well as supporting the DOE NE mission. And if so, we would ask applicants to clearly demonstrate how their proposal supports the DOE NE mission, even though it may be cross-cutting applicability to these other categories. And again, I wanted to reinforce the sentiment that this subtopic is primarily to allow for a area for applicants who have identified that their area of research or the proposed area of research does not quite fit into the other subtopics, but includes artificial intelligence, machine learning development. We highly encourage them to apply to this subtopic if they can identify another subtopic. That way, we're not missing out on any opportunities to leverage the AI community's developments in support of DOE NE. All right, so that is the end of my slides for RDO 5, and we can go on to RDO 6.
So RDO 6 would cover any proposals that are relevant to the overall goal of reactor development and optimization, but are not covered by RDO 1 through 5. And it's important to note that any submission to this category can be cross-cutting, but it must support the NE mission and at least one of the 4 goals listed below. So that's just a really brief summary of RDO 6. It's a catch-all for anything that would be relevant to reactor development and optimization, but not captured under RDO 1 through 5. And I believe this concludes our presentations on topic area 1, and we're going to move to Brian Robinson for an overview of IRP-1.
Hi, everyone. While we are waiting for that connection to occur, Janelle, if you're available still, do you mind if we proceed with questions for RDO?
Sure, I think that's a great idea. And then when Brian comes on, we can proceed with IRP-1.
Okay, great. And there's only a couple questions here. One of the first questions was asked early on when you mentioned NEST participation. So is NEST participation considered a positive in the proposal evaluation?
Right, so participation in NEST is not something that we consider when we review the proposal. It's an opportunity that's provided for the students, but it's not part of the relevancy review. So that's not factored into our decision-making process.
Okay, thank you. In the presentation of RDO 1, the advanced reactor development, new reactor designs are not considered to be relevant. However, quote, innovative reactor core and systems design or modifications, unquote, is included in the draft work scope. Could you clarify the difference between these two?
Right, so I think it's okay if you propose, modifications or improvements to current core designs, but in terms of focusing on a design exercise for the particular proposal, then that would not be considered to be as relevant. Now, if you can make a case for why that is needed and why that supports the goals of RDO 1, then that would be considered as well. But we're really focused on optimizing current designs and not so much creating new reactor designs.
Okay, thank you for that clarification. The next question is for RDO 5, so for Janelle and Daniel. A specific topic is on the list of current DOE support. Can we apply for that? So for example, the autonomous operation based on artificial intelligence is already supported. Can we apply for that topic?
So I would say that applicants should review ongoing research in the area of development of semi-autonomous or fully autonomous reactor optimization or operations, excuse me. There's plenty of landscape necessary to complete that task. So I wouldn't discourage applicants from pursuing that scope. I would just encourage them to review ongoing research in that area And that is something that if they reach out to the NEUP email, I can forward on additional information regarding ongoing work.
And if I can just add to that, really for all of the work scopes, so I don't think you should rule anything out because it's listed as currently supported. We're really looking to spark innovation here. So if you have a better, an improved way of doing it compared to what we're currently supporting in the program, that would be considered responsive. Of course, we wouldn't want to fund the exact same scope or the exact same way that we're currently doing it. But if it's something that's new and different, that would be considered responsive.
Okay, thank you. A follow-up question about the NEST participation. If it's not considered during the proposal review, why is it not a favorable part of the evaluation process?
So NEST, with this NEST program, we're providing an opportunity for the students where they're able to travel to other NEST countries and to interact with their peers. But the selection of the NEST projects, that gets done after the CINR project is concluded. So during the application process, you will indicate if you're interested in NEST, but we wait until we select the CINR projects and we decide which ones are going to be funded. And then if any of those, indicated their preference to be part of the NEST project, then the NEST program would consider those. But it does not impact the relevance of the work. It's just an extra opportunity, some incremental funding that can be provided for travel.
Thank you, Janelle. The next question, it starts off with thank you for an amazing presentation. So as a new faculty member coming from outside of the US with a background in data science and advanced nuclear design, and currently working in the data science industry, developing prognostic optimization methods for nuclear systems, is there any chance that I can reach out to the federal point of contact for potential feedback on ideas?
So Janelle, this is Drew Thomas. I'll take this one. When we have our federal points of contact who are available to answer questions, that's focused around understanding current ongoing work and program activities, as well as better understanding DOE NE mission space. When it comes to getting feedback on specific proposals, that's what our pre-application review process is intended to do. So if you weren't able to catch the presentation from yesterday on how the review process functions, please reach out directly to me or to the NEUP office at neup@inl.gov, and we can walk you through that process. But that's the intention of the pre-application review process, is to give an opportunity for feedback and evaluation of specific proposals and concepts.
And Drew, while you're here, we have another general type of question regarding any restrictions on citizenship for PIs.
This was also covered in yesterday's presentation, so I'd encourage you to review that overview presentation when it comes out online. The requirement is that applications come from U.S. institutions, meaning U.S. universities or colleges, national laboratories, or industry. That means that that requirement is on the institution to be a U.S. institution, and we do not have requirements on specific individual PI, co-PIs, or collaborators from that perspective.
Drew, I'd like to add to your response on the question about feedback on proposals. I want to add that outside of when a solicitation is open, the federal managers can be available to discuss ideas. It's just that during the period where solicitations are open, we can't give anybody an unfair advantage.
This is a good point. When we're talking about applications to a funding opportunity, there's specific rules that all federal points of contact and federal employees have to abide by. So yeah, thanks for that clarification.
And then the next question is also for RDO 5. Would a combined AL/ML and experimental proposal be of interest?
Potentially, yeah. So for that subtopic, it isn't limited to only having an AI ML component. The idea behind the subtopic is to encourage the AI community to support the Office of Nuclear Energy's mission. And if that proposal included an experimental portion to validate the AI or ML technique, then that would appear responsive to the subtopic.
And the next question deals with the other reactor subtopic. Does the other reactor scope support new reactor design?
So I think this is something that could potentially fall under IRP-1. Of course, you would need to make the case on how that design would accelerate the deployment of advanced reactors, but that could potentially fall under IRP-1.
Okay, thank you. And then within the RDO subtopics, is an economic assessment required for all of these work scopes?
Sorry, Julie, which scope was that directed to?
It was focused for all of the RDO scopes.
So no, right. So that's just a suggestion. That's something that you can consider in your proposal, but it's not required.
Yeah, in RDO 3, an economic assessment would be within scope.
Okay, and then lastly, is there an estimate of the number of possible awards for these work scopes?
And Janelle, I'll take this one as well. This is Drew Thomas again. This was in the overview presentation from yesterday, but we estimate there's going to be between 40 to 45 awards over all of the scope areas, and so it all is dependent on appropriations and the amount of available budget to be able to make those determinations. So we don't have we have a broad estimate, but don't have any details in regard to potential number of awards.
One last question came in. In the RDO 5 work scope, does structural design optimization include topology optimization?
Topology optimization, I guess I would ask whoever submitted that question to kind of expand and clarify on that, what specific topology they're referring to. But it may be applicable to the scope. Based on the question alone, it's hard to tell. But yeah, I would encourage whoever submitted the question to kind of provide some additional clarification, and we can try to answer your question.
Thanks, Daniel. And then another question did come in. Is it expected that NREC will be involved in these proposals?
Well, I think the universities have the opportunity to engage with our national labs as appropriate, but NREC participation is not mandatory, just like national lab participation is not mandatory.
Okay, thank you so much to all of our presenters and question and answer session. Our next session is the IRP Grand Challenge with Brian Robinson, and I believe he is on the line.
Yes, ma'am. Julie, can you have good comms?
Yes, we can hear
All
you
right,
just
great.
fine. Please go ahead.
Thanks for your patience on that. Had to log in and out 2 or 3 times. Yeah, if we could, let's just play. I want to give a little background here for the IRP-1 Grand Challenge IRP for accelerating reactor deployment. The subtext underneath is up to 3 years and up to $3 million. Again, you do not have to put in a 3-year package, and it doesn't have to be exactly $3 million. Sometimes we are looking for packages that are a little bit different in their structure, so just pay attention to this as you're putting your system together. I just want to emphasize that for a moment. Again, I am the federal POC for this, and I manage for the Advanced Reactor Technologies office is I manage the molten salt reactor, both liquid and solid fuel, and I coordinate that with Diana Lee. The fast reactor campaign will also be under my purview, and I will certainly be involved in these selections and coordination with much of our commercial industries as they start to advance in the ARDPs and the ARP-20 awards, which were briefed earlier in our presentations. Next slide, please. The Grand Challenge language was provided. I wanted to pull it out here so everybody had explicitly what we're looking for. So we have goals of demonstrating some advanced reactor types, but there are some time limits in the 2030s that need to be adhered to. One of our primary challenges is reducing the overall capital and O&M while reducing risk in the technologies. It goes back to the earlier question that we had about economics. It's not mandatory, but it's a strong suggestion that you would review these and provide that economic impact. Any solicitations for this scope take a holistic, multidisciplinary approach to reactor deployment for specific reactor technologies. And lastly, we should have innovative ideas for cost reduction or shortening the deployment timeline. This is a very key area for us as we're starting to go forward, looking at advanced reactor technologies and how to make them less expensive, more competitive, and safer as we go forward in our deployment. Next slide, please. We are looking for applications that can cover a wide variety of topics. I've listed some of these here. Innovative component instrumentation and fuel handling systems. Again, these are specific to the IRP Grand Accelerating Reactor Deployment and not fuel cycles. So you'll have to be explicit in making sure that some of these other areas are either complementary or explaining how it reacts or is pertinent to the IRP-1 and not these other topical area 3s and 5s. We're looking for design optimization, technologies to reduce cost and schedule, siting infrastructure considerations, and other topics. Now, other topics are relevant work topics not explicitly mentioned here will be considered if they support the grand challenge of accelerating advanced reactor deployment. I gave some examples underneath the first 4. Those are not meant to be all-inclusive. And also per the other topics, if you do have things that you believe you can submit, I would encourage you to do it, but make sure that it's complementary of other areas. It's also, it is not duplicative of work that's being done in our current programs or under our current R&D campaigns, and we'll address that in a moment. Next slide, please. As I mentioned, addressing it in a moment, I wanted to provide a list of just ongoing any work relevant to our IRP-1. I would draw your attention to the bottom of this slide where I've provided example of R&D that we're doing in our campaigns, but this is not exhaustive. And we're only providing this to give some indication of areas that you could look into to see if this is research that you would have that you would be interested in. And also, it would give you some indication that of what's going to be their future, ongoing and future research. Now, I wanted to just go through the real quick. ART program, we support a couple of these areas, the METAL, the Mechanism Engineering Test Loop, that's at A&L. This is an activity that is commonly used for our CINR, NEUPs, and could be used for our IRP. I would encourage you to use these links to go through to see what work has been done. For our MSRs and FHRs, I provided the liquid salt test loop, which gives you an indication of areas that you could consider. Also, under INRIC, we have some areas to reduce cost overrun and schedule slippage that plague the construction of nuclear power plants. I put this link in here, and of course, the last one is SNAP. This is looking at the microstructure and mechanical properties of materials in a reactor at high doses, and it's specific to using ion radiation. There are many others. I'll get to another slide here, but in addition to me, there will be program and project managers that are working at the national labs that can provide some insight, and we'll address that on the next slide. Next slide, please. So areas that we are not interested in, and you've heard this in several of the presentations, we want applications that are focused on the DOE NE mission. We're not looking for things that are relevant to non-proliferation purposes. We're not looking for fusion applications, anything to do with nuclear weapons, R&D, and the nuclear medical isotope production. Some of these areas are in other departments in NE and are not of interest for us. Although I will tell you that if you do have an application that can hit some of the crosscuts in these areas, you should discuss it and consider putting a proposal in. It may be relevant. There are some areas where there is a little bit of cross-cut or overlapping on the research. So, like I said, try and reach out to people if you do have an interest in these areas to figure out where they would go. Next slide, please. So, as I mentioned earlier, I would try and give you some links to our programs, some of the research that is being conducted out there, including some of the lab points of contacts. Now, quickly, you have in front of you a handful of links for the molten salt reactor, the fast reactor program, high temperature gas reactor programs, previous NEUPs, ongoing and previous SBIR, means, which is a big component here as we emphasize utilizing modeling to help us with our advanced reactor R&D. Our previous and ongoing gains are IFOAs that have been very complementary for a handful of years now. And I have provided my email back at the very end here so that if you have any questions, you can reach out to me, including if you can't find all the points of contacts on these areas, I'll certainly be available through my email to answer those questions. Again, these are not exhaustive, and they're just giving you some background of how to do some of the homework to make sure that your proposal is well developed, well matured, and is answering all of the asks that we have as we go forward. Again, this is a very broad and very difficult grand challenge to go forward with. So there's going to have to be some due diligence by the applicants to ensure that much of what you see in these programs are not repetitive, duplicative, and are complementary. Next slide, please. So with that, that's my last slide. Any questions, or are we going to defer this for another session since we had audio issues? Julie?
No, I think we'll go ahead and take questions now. Thank you so much, Brian. Anna Podgurney will be handling questions.
Great. So if anyone has any work scope specific questions, please enter them into the question part of the dashboard. Right now, we only have a general question that I'll address to Drew, and that is whether the federal program, the federal points of contacts, if they will provide a full exhaustive list of duplicative funded projects.
So from the intention of these presentations, including the web links that have been provided, the NEUP projects that are available, the abstracts that are available on NEUP.gov, is to provide that context. And I would continue to reinforce that our federal program points of contact are listed on the draft work scopes. And we do plan on having additional engagement opportunities to continue to ask these questions if there's clarifications after you've looked through those resources to try to make those clarifications. As a reminder from yesterday's overview, we do plan on organizing an engagement opportunity, so what we're terming like office hours, to be able to have those open conversations with program managers about what potential ongoing work there is, and give any investigator, any potential applicant, the opportunity to ask those direct questions of federal program managers if you need clarifications about what ongoing work is there, and where gaps are, and those types of things. I will remind everyone that the shift that we've made in the program this year creates an environment where there's more of a NE mission relevance focus rather than a program priority focus. And so it's an important distinction from a administration standpoint and from a review standpoint as those things are evaluated. So that's a reminder as well. I'm hoping these continued engagement opportunities will give you the opportunity to make any clarifications you need.
Thank you for that, Drew. Brian, we did have a question come in regarding the IRP. Is it possible to combine different scopes of the IRP if they are related? So for example, design optimization and reducing O&M costs. Also for this case, is it possible to negotiate the budget beyond what's specified?
So the second part of that is probably more of a question for Drew. I believe the answer, Drew, is no, but you could probably answer that.
That's correct, Brian. Yeah, the limits that are set at the start of the presentation are the upper limits for that budget and time duration.
And to the first point, it really is going to depend on how the proposal comes in. So my experience, I have seen somebody or an applicant that will want to shore up two different areas. So they may address both of them in their proposal, making reference to another area. A good example of that would be advanced reactor design and fuels. You may want to submit something in fuels while you also want to submit something in advanced reactor design. Now, what I wanted to ensure is that there isn't going to be any crosstalk of partial, of one area in a IRP in another area that may be, in this case, fuels and design. You would submit one with IRP-1 in my case, and then you would make reference to it in a fuel and submit it over in fuel. As far as I'm aware, unless something has changed, and I'll put this back to Drew, there is no combining, merging, or pieces and parts that we're looking, but we're looking for a clear delineation between each one of these topics and subtopics. Is that correct, Drew?
I may need a little bit of clarification on the question, but I think this accelerating reactor deployment IRP is rather broad, so that's within that scope that Brian described, those things are options. When it comes to the other topical areas, I think those will each be outlined about what the general topics are. And there's, as a reminder, there's the other category in each topic area in case something is cross-cutting and you feel like it doesn't appropriately fit in a specific subtopical area. Is that what you're getting at, Brian? Is that what you were trying to drive toward?
Yeah, I think that's kind of my point. I mean, if they're going to apply to a crosscut, that's different. But if they're going to try and force a crosscut by merging other areas, I would encourage them to try and look holistically into the areas and see if they can just apply directly for it.
All right.
Okay, it looks like that's all the questions we have for this session. Thank you, Brian, and all of our other presenters in the RDO topics.